Okay, very good, very good. Okay, in the first test, I cleared 10 out of 10. So that means that, okay, that's easy for me. So the system, the adaptive learning system will learn about my potential. And then the next test would be somewhat a little bit harder. Maybe Sendil is just 7 out of 10. Sai would be uh, maybe 5 out of 10. So based on the methodology, based on each and every individuals, the next test it is going to be adaptive. That means it is giving you more and more options to clear those kind of tests, so that you will be engaged more. Okay, so you'll be engaged more, and that technique, I mean, the adaptive learning technique. I mean, this is what every school, even colleges try to, but it is not, not in India especially. It is the adaptive learning just in the system itself. It is very very impossible, or I mean, impossible to implement in our education system as of now. But if it, I mean, if we are ready to, get this kind of information, then that is going to be the huge achievement in education sector. So depends on the each and every individuals. It is, the system will give you the recommendation process. Okay, so that is called as adaptive learning. So Adapt Boost, it is getting, based on the weak classifiers, adaptive boosting, and this prevalent boosting technique that combines multiple weak classifiers into a single strong classifier. So you don't want to mention, okay, it is very, very getting weak. And so we are just, applying this adaptive boosting. That adaptive boosting, it is automatically, learned by, itself based on the weak classifiers and how much we need to boost, and how, I mean, to some extent, or to more extent, or the most extent. So it will decide based on the adaptive learning nature. So this is what, is called as adaptive boosting technique. So ADA boost we used to call. So for, there are so many other boosting techniques. Mostly XG boost will be using, and the ADA boost will be using for most of the boosting techniques. That is a standard practice. And based on your requirement, we will be able to get to know about what kind of other boosting techniques like GBM, right GBM, and CAT boost. I mean categorical boost, and we will be using it. Mostly, ADA boost and XG boost would be one of the uh, boosting techniques. Okay. So now, yeah, this is one of the other instances how uh, I mean, based on the majority voting, how a fruit can be classified. Okay, so I mean, you can just easily adapt to this kind of a visualization. So this is an instance, and you can just make a tree. It is not trying to decide. Okay, this is tree one, this tree two, and tree three. I mean tree n or whatever it is, right? It just goes on, and multiple trees possible. Not like, I mean, that is why we are coming from decision tree to random forest, because that is the problem statement, and that is why we are choosing this algorithm. So n number of trees is possible. So this, the class A just identify something, and class, this is one, and this identifies, okay, this is a banana. Now majority voting, like from these two, it is getting unidentified, this is an apple. So the similar case, um, maybe during the chat GPT environment, if you keep on asking some questions, and your response, I mean, you closely observe, this random forest classification, how does, you will be getting the response. At one point in time, it will just stagnate. I think we have discussed this example during this decision tree and something else. at one point in time, if you keep on asking the same questions or even the a similar or uh, differentiation with the word, but still you'll be getting the same responses. That means that decision tree just stopped there itself. Okay, and then based on the majority of the I mean whatever the phrases you have given, it's already decided and that's it. Okay, so that is also you can close the watch. I think we had a discussion on this. Okay, so let's, I think, the diversity purposes, and we have already seen robustness, handling of missing values. Yes, it can handle missing values internally by using surrogate splits or by averaging results from other trees that do not have any missing values from the same data points. So handling missing values, it is really one of the features. The feature importance, it provides insights into the importance of each feature. It can be particularly useful for feature selection and understanding the underlying data patterns. Scalability can be parallelized because each tree is built independently of the others. This makes it scalable to large datasets and high dimensional data. Versatility, yes, it is really, I mean, entirely different from other algorithm. It has its own uniqueness. Can be used for both classification and regression. The algorithm is also effective for the task involving categorical stability and out-of-bag error estimation. This is one of the classical feature. So random forest provides an internal mechanism for estimating the model error without the need of a separate validation set. So during the training and testing process we have done already, but still it is also, I mean, random forest also will check internally for validation purpose. So this is done using the out-of-bag techniques, out-of-bag samples, which are not used in the construction of each tree. This is really, and also, you might know or you should know the difference between the decision trees and random forest. Okay. Random forest is a comparatively slow process, and random forests are created from subsets of data, and final output is based on the average or the direct ranking, right? So, hence, the problem of overfitting is taken care, and mostly overfitting concept never works in random forest. It randomly selects observations, builds a decision trees, and takes the average result. It doesn't use any set of formulas. Okay, the decision tree normally suffer from the problem of overfitting because we never know on which tree we have to block, we have to stop. And the single decision tree is faster in computation. When a data set with features is taken as an input by a decision tree, it will formulate some rules to make predictions. But in random, no. Okay, right. So we'll see one by one of the implementation. Okay. Can you just open assemble or side and just open this code in your thing, and then we'll be discussing the n estimators, criterion, entropy, and now we have to discuss each and every point in depth. Okay, just
Okay,
open
sir.
in your open in your thing, and then we'll see.
You want to share my screen?
Yes, I will give you access.
Random forest, right?
Mm. Stop
You
share.
give me control.
Yes. Yes, I have given.
Okay. Just let me know.
Yes. Yeah. We're able to see.
Okay.
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 So,
So,
yeah, you can just run each and every block.
yeah, this is a normal, what is that?
Normal.
NumPy,
Yeah.
Matplotlib, Pylab, Pandas. Okay. And importing dataset from social network ads.
Mm.
So here we are creating X and Y, this one, values.
Yes.
Okay. And splitting, we use that import train test split model, and using that we are training, like train and test data sets getting splitted. And this is the value of X value.
Right.
And this is a Y value. This is the test value of X, and this is the Y test value. Now we are going for the scaling. So we have to standardize the value of both X and Y. So we are taking train and test data set, X train, X test. So using the standard scaler, pre-processing, and we are transforming the data. That means in X test and X train. So we are transforming of train and test data set using that fit underscore transform. So this is the value of X train. So now X train got some standardized value.
Standardization, yes.
Okay, using the feature scaling. And this is the value of X test value. It's a train value and test value. Now we are going to implement the random forest classification. Okay, so before going into that, can we able to see can you able to visualize any data from this train and test data?
Yes.
You
So
said like
maybe you have to perform some visualization. So what we have to do, maybe go to Cloud or ChatGPT, give the code then until pre-processing. Give the code until pre-processing. This is one of the hacking. How you give the code until pre-processing. Give the code
until we have to
or until free feature scaling. Until give the feature scaling until feature scaling. So maybe
so we can't copy completely. Okay, one by one.
Yeah, one by one we have to, because it is a code written block.
Copy.
Until you renamed this program as classification, or it like a different?
It's a random forest classification only.
I'm not able to locate that in the.
Oh, this is actually I copied from here. See here in our this one classification, random forest classification. So I just copied this IPYNB file and paste it there.
I am not able to locate that. 1 minute.
Go to M2Z, this one.
Machine language in that classification. Under classification.
In that Python. Here random forest classification. Okay.
Maybe what you do, you take a document, open up
this one we can copy directly this one, Sini.
Yes, yeah, you can copy this.
Okay, let me
upload same file.
Yeah, okay, you can upload to Claude and then ask
okay.
I want to, you can upload, I mean, no, not here, in Claude itself. In Claude, yes, you can upload Python file.
PY file, no? One up.
Yes. Now ask, I wanted to visualize. I wanted to visualize. After pre-processing the data set. How to do that? Yeah, this is how we have to answer.
So, Srinivas, here we are attaching PY file. Is IPY, NB and PY both files are same?
Yeah, both files are same. So IPYNB, it's nothing but it's a notebook kind of a thing, right? And that means you will be having any kind of a notes. Because yeah. So maybe written information, right? So notes is having a separate kind of information. Will be having. It is not only having only the code. You'll also find in some of the notes.
To visualize the data set after pre-processing, we can create a scatter plot of the features. Since you have already performed feature scaling, we will need to inverse the transform data to get back to its original scale for the better interpretability. Here, how you can do this. So visualize the pre-processed data sets. This code will create a scatter plot.
One in the right side.
Yeah, this is the code actually.
So you can just
so it uses the inverse transform data to show the original scale of age and estimated salary. Each point represents person in the dataset. Color of each point indicates whether the person purchased or not. X-axis age and Y-axis represent salary. A color bar and legend are added for the better interpretation. To use this visualization, make sure you have already performed data pre-processing steps, like splitting the data and applying the standard scaler. To copy and paste this code after pre-processing steps in your script. Run the code to generate the visualization. Okay, here, let's see, train original. And then we put this one, label, and see. Okay.
Now down you can have the option of copying this code. Down.
Here.
No,
download
before
the file.
Before that. No.
Oh, this one.
Yes.
Copy the contents. Okay. And where is the code? Let me
paste it
here.
You can create a block.
After pre-processing, right?
Yes.
This one. Before pre-scaling, in this one, right? Or after this one?
You can apply anywhere. I think before feature scaling.
Okay. Feature
Whenever it is going to represent wherever.
Because they're saying it is inverse transform. So now it is transformed the data. Okay. Then we have to visualize and how inverse transform means it will take the original value, right? See, for
original
example.
Value, yes.
Okay. So we are doing the transform already, and we have to apply after this step. So we'll what is it? Inverse that particular transformation.
Fine.
Okay. Let me copy this after this print statement. Okay. I will copy the code here. Here.
Just control
how to copy.
Control
V. Okay. Okay. Here not need. This is not needed. Okay. So here we ran till this. Okay, let me run this one. Oh, pre-process data visualization. So how now the data looks like here. Okay, this is the age, and this is the salary estimated one, and target purchased or not purchased. So this blue color is not purchased, and these are all purchased section. Okay, the purchase section is increased when the salary got increased. That means if you see the outliers, that mean the data spread, you can most of data points are fall under the what is that?
Age you should see.
Age, yeah, age and salary. If you take majority of the data points not purchased comes under less age and less salary. And age increases.
No, less salary also there is purchase, but their age is more. If you see 20,000 to 40,000 scale, there are quite considerable amount purchased, but their age is between 40 to 50.
50 to 60.
No, 40 to 50. There is a cluster of people, if you see, their salary is between 20,000 to 40,000 only. But age group like 40 to 50. So that is the number of people, group of people who may.
This is spreading. This area is a little scattered. Like what is that? Yeah, salary got increased and the age also. And even for the less age also, the who got higher salary, they go for the purchase. They went for purchase too.
Likewise, if you wanted to analyze any other columns, that's also okay. You can change it.
Okay.
I mean, this is how you have to. But this is one of the techniques. Okay, so each and every machine learning concept you are learning, wherever you wanted to visualize, this is one of the hacking techniques. So you have to just make it visualization. Then only you'll be able to understand what kind of the techniques we are going to apply, and visualization is very, very important.
With the data we can't visualize, we have to interpret through some graphs actually. See, for example, I am seeing this data. This is a standard scalar data. This is a feature scaling done, but we can't interpret anything on this. So this is the data on the original data, not on in standard scaling data. This is the inverse transform on original. That means it will get back to the original value, and the original value, and we are interpreting through the scatter plot. Okay.
You can just play around whatever you want.
Okay. Now we are going to train the model on random forest. See, train fit. This is X train and Y train. There we are fitting that using the estimators and criterion entropy.
Yeah. Now what we have to do? Okay, I will send this link. And just what I mean. Ask Claude, what is n underscore estimators? We have to break down each and everything, because each and every element is important in the pattern classification.
N-estimated parameter in random forest classification is an important hyperparameter that defines the number of trees in the forest. So it defines the number of trees. Each tree in the forest trained on the random subset of the data, bootstrap sample. When making prediction, each tree in the forest votes on the outcome. The final prediction is typically majority vote classification or the average of regression of all the trees.
So one other point. I mean, this third point. Just read out the third point.
Impact. So generally, increasing estimators improves the model performance and make the predictions more stable.
So that is why we are choosing random forest. We never increase the decision tree in decision tree model. Never increase the number of trees. If we increase, there is a possibility of overfitting. But whereas in random forest, we are doing it in the opposite direction. Okay, so how many number of
Overfitting is the biggest issue in the decision tree. So it won't handle it properly. So that's why we choose a random forest to handle that overfitting, especially the outliers. The main outliers or many things are there. Then the time we can go for the random forest to standardize the sample.
Okay. So how the fourth choosing a value for the code example? Yeah, this is what it is. Okay, tuning. So tuning, you can tune. There is a tuning is there. Criteria, entropy. Entropy we have done. The sixth point is tuning. Tuning, you can tune this parameter using techniques like grid search or random search with cross validation to find the optimal number of trees for your specific problem. So that is called as performance tuning. So we have already.
That means we have to, what is that, trial and error, like 10,
Yes.
11, 12.
Yeah.
So tuning kind of.
It depends on the problem statement, what you are working. That is why I asked you to practice so many GitHub problem statement or Kaggle problem statement, so that the researchers will be doing or will be analyzing those machine learning, especially with a different implementing different problem statement for different domains. So it is not very simple. They won't take a very simple problem statement. They will take a huge problem statement for a bigger variety of domains like healthcare, life science, banking, or any other, even energy consumptions, and those areas. It's very vast. Even market research, right? It is not like we never explore those kind of information. That is why we'll see some of the examples today, and then we will just close this round of first. Okay. So this is what Bootstrap we know alpha, weight, and everything. Yes, see. Estimate is 10, random state.
Now training on the train dataset. That means, using the train dataset. Okay. And here predicting a new result. This value, for example, so this is what we discussed, right? So majority of the cases within the thing, like the prediction happen within that boundary. So if you go beyond the boundary, I think that model, it won't give the correct fit. So that's what we learned, right? See, for example, 30 and 80. For example, I'm opening this Excel. Minimum, maximum, right? So we've seen. See, if we see this 30 is within this particular range.
Right.
35, what is the maximum? Maximum, okay. So if I want to go beyond that, I think it won't give the correct fitness. That's what what is that discussed, right, previously.
Right. So what you do, if you have a question in this prediction, already you have given attached to Claude, right? Just ask how do I interpret this line of code? Just ask this question. How do I interpret? Yeah, just copy this. How do I interpret this line of code?
So, one question I have, Shin. In this code, if you are seeing, first we have already trained the data set. Then we are performing feature scaling. After feature scaling.
No. After the feature scaling only we are training.
No. If you see the code, there is training before and only.
So after feature scaling only this training is happening.
No, training never happened before feature scaling. Right?
No, splitting the data set into
maybe
the training.
Yeah, you are splitting. Splitting can happen. But it is not that, the training means the model training is happening after feature scaling.
Yeah. So this training is based on the feature scaling side. This X train and Y train, we use that.
Got it. Okay, no investors.
Yeah.
How do I interpret print classification?
Estimated, then criteria, and
let's break down classifier of 30. This is the input data for which we are making a prediction. It represents the single distance with two features, 30 years old and estimated salary 87,000. Times on this applies same scaling standardization that was used on the training data to our new input. This is crucial because the model was trained on scaled data. So any new data must be scaled in the same way. Can I predict the value beyond the boundary or outside of the value, outside of scale data, can I mention? Outside of the scaled data. Yes, you can predict the values outside of the range of your scaled training data, but there are important consideration potential issues to be aware of. Extrapolation. Predicting outside range of your training data is called extrapolation. Machine learning models, including random forest, can make the prediction on such data, but reliability of this prediction may decrease further you get from your training data range.
That is called
model
extrapolation.
Extrapolation. Model behavior, random forest being based on the decision trees will still give you a prediction for values outside the training range. The prediction will be based on the rules learned from the training data applied to the new unseen values. So you mean to say the random forest?
So it is possible. I think this is the same kind of a question last time also, we have faced. But for that particular model, we will not be able to get the, I mean, it is possible, but you won't get the predicted value. You won't get the expected value, expected predictions. And prediction may not be true to the expectations. That is also there. So here, what they are saying, random forest, because we are doing a lot of decision trees training, and also based on the decision tree information, we are scaling up. But there are possibilities you will be getting the extrapolated information. That means it will give extra information. Okay. Extra model information.
See, for example, let me run this one. I think 0. That means what is the output of this? 0 means
again they'll ask the same kind of see how the transform is working over here. So previously, the previous prediction result, what did we get? How do you, again, that is why I asked you to make a there is one more thing. Go up. They have given a sample of information. Let's see.
If it prints 0, the model predicts a 30-year-old person with estimated is not likely to purchase the product. Okay. I mean, okay.
So already 0 or 1. Okay. So that is the expected thing. That is a binary value we are going to work on. Because it is a categorical one. Okay. They will buy or not. Okay.
Correct.
They will buy the product, they will not buy the product. Right. So if it is the case, then the person likely won't purchase the product. Okay. So then how do you, so that is why the classifier predict. So,
okay, let me see, for example, here we are seeing 30 years of age and 87,000. That means it is beyond this one. So it is coming like not purchased. So 30 years of age.
Right. Yeah.
And 87. This is the range. This is the point actually. So it is predicting like, okay, there is no, he can't purchase, like 0 not purchased. it is the value is predicting is 0. So based on the data points.
Yes.
Correct. And we see, for example, I am getting value of age 30. Okay, where is the age 30 range?
I can take 32. Because we don't have
32. 32 is
29. You can take
18,000.
29. Yeah, you can take 29.
29 is 80 and 32 is 18,000. So if I look for the value 30 years of age and 87,000 estimated salary. Okay, so there is no such value. That means it automatically go into 0. That is how it is predicted actually. 31, 80, 31 also 18,000. So there is no such estimated salary of that. We don't have the value, but we trained on this thing. And based on the trained thing, it is getting, what is that, predict the value. 1,35,000. You see, 30 years of age, we have
$1,35,000.
1,35,000 we have, but 31 years
salary.
80.
That's a salary.
Salary. Yeah, salary. 89,000 values also we have. 89,000. So now we are predicting 30 years of age, it is 87,000. So we don't have 87,000, right?
So the model, how it works, so we have some information. Okay, it is like 1 to 10. I mean, salary or whatever it is. I mean, even say for instance, 10 informations we got trained. And now you are trying to take out a value of, I mean, predicting the value of 7.5. We have already got trained until 1 to 10, but we are going to predict the value of 7.5. We can't say that it is not trained because it already we got trained until, I mean, from 1 to 10. And it is the model's ability to find out and predict the value of for 7.5. Based
within
on
the range.
Within that range. And also based on the decision trees, and also based on the random forest classification model, right? Because it has the ability to find out and predict automatically. It is not that you are going to train it again and again, because we already trained the model based on the historical data, right? And also it has the ability to predict the current value scenario too. But ultimately, the point is you have to train before prediction.
Yeah, mainly the problem comes when you are doing extrapolation. So outside the range, if you go with the outside range, then only that what the reliability of that particular data might have a question mark. So if anything, if we trained within the range, it can predict 100%.
So that's the problem. That is the problem when we are encountering the weather predictions, especially for India. The Indian government, maybe their skill. I mean, they have a skill, they have a lot of things, but the problem is the decision making. Mostly, see, in tropical countries, that is the weather is also a problem, challenge one. But we have enough, historical data. But the problem is we are always, the current data we are expecting, right? The future, how it would be. But those kind of information we never got trained. That is also one of the problems, because in Europe or US, UK, they have a very good model. If they are saying that this will happen at this point in time, it is happening because their ecosystem is great, and their every